Welcome once again to this online session where we are discussing various diode circuits. And today, what we would discuss would be voltage multipliers. Let me share my presentation with you. Let us try to understand what do we mean by voltage multipliers. Voltage multipliers are basically circuits which provides a DC output that is multiple of the peak input AC voltage. To understand this circuit, the circuit would take input as AC voltages and would give output which is DC, something similar to a rectifier. However, the DC output that I would get would basically be the multiple of the peak of the input AC voltage. To make it simplified, let me give you an example. If I say that I have a voltage doubler circuit, this is one of the type of voltage multipliers, voltage doubler circuit. The word doubler means double. So a voltage doubler circuit will provide a DC output that is twice the peak of the AC input voltage that we give. That is, if the input voltage is Vm sin omega t, the output voltage would be equal to 2 Vm and this would be DC. Similarly, if I have a voltage tripler circuit, so we expect that the output DC voltage would be 3 times the input AC voltage. So again, if the input AC voltage is Vm sin omega t, then on the output side I would get DC which would be equal to 3 Vm. This voltage multiplier circuits, voltage doubler and voltage tripler are both examples of voltage multiplier circuits, consist primarily of diodes and capacitors. And the basic philosophy behind this circuit is that we connect capacitors such that the value of the voltage stored in the capacitor or the charge stored in the capacitor basically adds. So we would, as we would discuss the circuit, we would understand that each capacitor in the circuit would be charged to the peak voltage, say Vm, and the capacitors would be arranged such that this voltage gets added. Where do we find applications of such voltage multiplier circuits? Then these are used in many applications where we need high voltages from relatively limited input voltage, but again, such applications do not need high current. So what is multiplying is only the voltage and not the power. So once again, let me restate this, that this voltage multiplier circuits are used in applications where we require high voltages to be generated without need of more current. The examples of such applications can be inside our oscilloscope, CRT, cathode ray tube, which is there inside the oscilloscope that we use in laboratories of basic electronics. Such voltage multiplier circuits are used to generate electric fields. Similarly, I may have some testing equipments, particularly insulation testing equipments, where I require high voltages to be generated. Another common example of use of voltage multiplier circuits is microwave oven. In this session, we would try to discuss two types of voltage multiplier circuits, the first being voltage doubler and the second being the voltage tripler circuit. Let us start with a voltage doubler circuit. The circuit configuration of voltage doubler circuit is shown here. I primarily make use of two capacitors, C1 and C2, and I do have two diodes, D1 and D2. We can consider that I may have a resistance RL connected here, across which I take the output voltage V0. RL is not shown here. RL is not shown here, but I may have a load resistance connected here. And we generally assume that the load resistance is very high. For the ease of understanding this circuit, I have labeled different positions in the circuit as A, B, C, D, E, and F. Let us start understanding this. During the positive half cycle, terminal A would become positive and terminal F would become negative. And we can immediately understand from this that diode D1 would become forward biased and D2 would become reverse biased. So, what would be the path for the current to flow? The current would flow in the loop starting from Vn to A to C1, C1 to B, B to D1, D1 to E to F, and back to the source. So in this, I do have a diode which is forward bias, which acts as a short circuit. So in this loop, the resistance is primarily zero. So time constant is zero. So this capacitor would immediately charge as per Vn. So capacitor would charge to the peak voltage Vm, after which the diode D1 would become off or reverse bias. This is something which is similar to the clamper circuit that we have discussed in previous online session. So during the positive half cycle, C1 would get charged to Vm. During the negative half cycle, terminal A becomes negative and terminal F becomes positive. This would certainly make diode D1 to be in a reverse bias state, but it would bring diode D2 in a forward bias. Why? Because N terminal is connected with negative. This negative is supported by this capacitor voltage C1, right? So D2 would become forward bias. So now the loop would basically be this. So the current would flow in this loop, and which can be marked along the path. You can follow my cursor. It would start from Vn to F, F to E to D, D to C2, C2 to C, passing through D2, B, C1 and A. Now if you see this loop, then one voltage source which is present is the input voltage Vn. Another voltage source which is present here is this capacitor which is charged to Vn. So if we try to find what is the peak value of voltage that can be in this loop, then it would be the peak voltage of input voltage equal to Vm and the peak voltage, the voltage stored across capacitor C1 which is equal to Vm. So the total voltage in the loop is Vi plus Vci. They are in addition because A is negative. So positive and negative would be in series addition. So the voltages are added, input voltage plus Vc1. The voltage across capacitor C1 is Vm. Hence, the capacitor C2 will be charged to twice the peak of the input voltage, that is 2 Vm. So this capacitor would charge to 2 Vm. Again in the positive half cycle, your diode D2 gets reverse biased. Capacitor C2 will be discharged through the load resistance RL, which is not shown here. But again, if we assume that this load resistance is very large, then the discharging of C2 would be very slow, and hence we can assume it to be maintaining the voltage 2 Vm. If we see the output here, once the capacitor is charged, capacitor C2 is charged to 2 Vm, it may discharge, but the discharge is very slow. Again, when I would have a negative half cycle, C2 would again get charged to 2 Vm. So this process of discharging is very slow. So we can assume that the output voltage would almost remain to be equal to 2 Vm. Thus, as the output voltage is twice the peak of the input voltage, we consider this circuit to be voltage doubler circuit. You may pause the video here. You may go through the explanation once again if required. I am sure you will be able to get this. Let us move on to the next voltage multiplier circuit, which is basically a voltage tripler circuit. Voltage tripler circuit is a natural extension of voltage doubler circuit. You can see the circuit here. If I consider only this part, A, B, C, F, G, H, then this is basically a voltage doubler circuit. You can compare it with the previous circuit that we have discussed. And I am able to get the voltage to be equal to 2 Vm. So what I have done, I have extended one more loop here, which consists of a third capacitor C3 and a diode D3, right? What happens in this circuit? Again, for the sake of understanding, I have marked different positions in the circuit by A, B, C, D, and so on. Here in the voltage tripler circuit, I will be taking the output voltage between A and D. So output voltage is basically summation of voltage across C1 and voltage across C3. As discussed earlier, the whole idea behind the voltage multiplier circuit is that charge each capacitor to the peak value and arrange the capacitor such that you basically get addition of the voltages across capacitor. Right? Let us try to understand this circuit. During the positive half cycle, D1 would get forward bias, D2 and D3 would get reverse bias, and because of this, the capacitor C1 would get charged to the value Vm. Here the current would flow in the loop of A, sorry, Vn, Vn to A to C1, C1 to B to D1, D1 to G to H, and back to the input source. So this capacitor would charge to the peak voltage of Vm. During the negative half cycle, diode D2 would get forward bias and diode D1 and D3 would get reverse bias. So the current would basically flow in the loop of V in H, H to G, G to C2, C2 to F, F to diode D2, D2 to C, C to B, C1 and A. So now, as it was happening in the voltage doubler circuit discussed previously, the net voltage to which the capacitor C2 would charge would basically be the addition of Vin plus Vc1. So the peak voltage of Vin is Vm and the voltage stored across C1 is also Vm. So Vc2, that is capacitor C2, would charge to the voltage value of 2 Vm. Now, in the next, that is in the second positive half cycle, what would happen? What would happen is that now initially in the first positive half cycle, D1 was getting forward bias. But at that time, the voltage across C2 was zero. It was not charged. Now the voltage is present across C2. It is charged to 2 Vm. So this terminal, the N terminal of the diode is charged to 2 Vm. This would make D1 reverse bias. D2 by natural convention, the way in which it is connected, it remains reverse bias. So the diode D3 would become on in the second positive half cycle. So the current would basically flow in the loop of A, B, C, sorry, starting from V to A to C1, C1 to B to C, C to C3, D, D3, E, F, C2, G, H, and back to this. So basically my loop is this, simply understanding. Right? Now in this loop, what is the value of the voltage that is acting? I have C2 which is charged at 2 Vm. I have input voltage whose peak would be equal to Vm, and this would be in supporting condition because in positive half cycle A would be positive, H would be negative, negative and positive would be supporting. C2 is discharged because while charging, C1 is discharged because in the negative half cycle while charging C2, C1 is discharged. So now what would happen is that this total of 2 Vm plus Vm, 3 Vm voltages would be across A and D. So we can say that C3 gets charged to 2 Vm, this gets charged to Vm, and the total voltage between A and D would become equal to 3 Vm. Thus, the output between A and D would get a total voltage of 3 times the peak input voltage. And as the output voltage is 3 times the peak input voltage, we consider this to be, we say this to be a voltage tripler circuit. Again, we have considered that in the output that there might be some load resistance, and that load resistance may cause the voltage across the capacitor to discharge. However, if this RL is very large, then this discharge will be relatively slow, very less. So we can consider the voltage to be remaining almost constant to be equal to 3 pm. So these are two different examples of voltage multiplier circuits, voltage doubler and voltage tripler. I hope you would have understood this. Thank you for joining this session. Thank you.